So now we shall go for the exercise problems. Exercise 5.5, first problem. A bridge has a parabolic arch that is 10 meter high in the center and 30 meter wide at the bottom. So the bridge is having 10 meter height at the center and the total width is 30 meter. Find the height of the arch from 6 meter from the center on either sides. That is, a parabola of this form, the center height is, that is the maximum height is 10 meter and then the width is 30 meter. So I can say this one is 15 and this one is 15. Now they need a height of, what is the height from the center? Maybe 6 meter. So this is, suppose if I take this one as y1, this height needed. Similarly, if this is 6, there will be a height, this height is given. Both will be equal because the curve is symmetric. Now, listen here, for this parabola, I need on what side it is open. So we shall take the curve is open downward. So this will be the vertex. So vertex will be 0, 0 at this point. So if I take this point, this is 6, y1. Now the curve is open downward. So all these points are in the fourth quadrant. So this is 6, minus y1. Similarly, this length is x is 15 and y is 10, but in the fourth quadrant this is minus 10. So we shall find this y1 now. Let the curve, let the parabola be open downward. Then its equation is curve is symmetric about x or y axis, so x square open downward means minus 4ay. So curve is open downward means it is symmetric about y axis, so it must start with x square minus y axis, so minus 4ay. Now this is known point and this is unknown point. So let me take the known point first. Now 15, minus 10 lies on the curve. Then equation becomes 15 square equal to minus 4a into minus 10. 15 square is 225. So let's say 10 equal to 4a. So straightly I can say 4a is 22.5. Instead of finding 4a, instead of finding a, let me find 4a. Therefore equation is x square equal to minus 22.5y. Instead of 4a I can substitute. Now this is the equation of the parabola for this particular curve. Now let me take this point. 6, minus y1 is a point on 1. Now this is, then the equation becomes, 1 becomes, instead of x, 6 square minus 225.5 into y minus y1. So it is 36 by plus 22.5 equal to y1. Or shall we say this one as 360 by 225 equal to y1. Therefore y1 is, when we divide by 5, it is 4 times 5 times, and this is 7 times 35, 2 times. Now I can divide by 9, 8 by 5. So y1 is 8 by 5 means, when I divide 8 by 5 1 times, 5 remains to 3.06 times. So it is 1.6 meter. So y1 is 1.6, but this is not the height what we need, because I have to find this height. This height means it must be measured from this place, because here is the vertex. So suppose if I keep this one as ABC, I have to find AB, so I have to find BC, but what we have found is AB only. So this means from the diagram, AB is 1.6 meter from diagram. Remember, I have to measure only from the vertex. So in order to find BC, shall we write like this? Therefore, I need the diagram, so let me write here. I need BC. BC means, is it not AC minus AB? The full height minus this AB. So AC is the total height, which is 10 meter minus 1.6 meter. Therefore, is it not 8.4 meter? So the height is 8.4 meter. Now, second problem. A tunnel through a mountain from a four-lane highway used to have an elliptical opening. So, a tunnel is having an elliptical opening. The total width of the highway, not the opening, used to be 16 meters. So, the tunnel opening must be 16 meters and the height at the edge of the road must be sufficient for the truck 4-wheel drive to clear. So, if it is at 16 meter opening, then a truck of 4-wheel drive can enter into that elliptical road, into the tunnel. So, if the maximum height is 5 meter, then what is the width of the total ellipse? That's what they are asking. So, they gave the tunnel opening, they are asking the width of the total ellipse. Be able to follow. That is, if I have a diagram, this is the tunnel entrance. Okay. Now, the center is maximum height, which is 5 meters. This was the highest point of the opening used to be 5 meters. So, highest point is 5 meters. Then there is an opening of height 4 meters. The height of the edge of the road must be sufficient for a truck to enter. So 4 meters. So this is also 4 meters. So this width is 16 meters. This is what they gave. This width is 6 meters. That means what is this opening? This length is what? This is what they are asking. Okay. So if it is 16 meters, so then this will be 8 and this will be 8. So this point I can say as 8, 4. 8, 4. Remember, it is not parabola, it is ellipse. So we can have the point. So if this is the center and this is 8 and this will be 4. So 8, 4. That is being in the first quadrant itself. Suppose if I take this one as x-axis and this one as y-axis. Now, the ellipses. So we shall take the major axis as x-axis. Therefore, equation of ellipses. Equation of ellipses. X square by a square plus y square by b square equal to 1. Here the total length is not given, but they gave the height. They have given height at the center equal to 5. That is, this implies, is it not b equal to 5? Then equation becomes x square by a square plus y square by 5 square equal to 1. So if I take the point 8, 4 is a point on the ellipse from the diagram. 8, 4 is a point on the ellipse. Then equation becomes, if I substitute x as 8 and y as 4, I get the value of a square. So it is 8 square by a square plus 4 square by 5 square equal to 1. From this we shall find the value of a. That is 64 by a square equal to 1 minus 16 by 25. 64 by a square is 25 minus 16 is 9 by 25. Therefore, a square is 64 into 25 by 9. So, a is root of 64 into 25 by 9. That is 8 into 5 by 3. Therefore, a equal to 40 by 3. Therefore, shall we say a equal to approximately 40 means 11 times 33, 12 times 36. 13 times 39, 30 point, then I have 1, so 3 meter or centimeter, meter. Therefore, length of the opening is, length of opening of the whole way, opening is 2a, isn't it? So 2 into 13.33, it is 66.26 meter. So the width of opening will be 26.66 meter, so that in which the tunnel opening will have 16 meter width, so that a height of 4 truck can height of 4 meters can easily pass through this canal. So this is the total width of the area. So can you understand? They gave the width at the opening only and they are asking the total width of this column. The total width is 26.66 meters. Next we shall go to the third problem. At a water fountain, water attains a maximum height of 4 meters at a horizontal distance of 0.5 meter from the origin. So water, the fountains are coming from the origin. If it is 0.5 meter, the height of the fountain is 4 meter. If the path of the water is a parabola open downwards at the origin, find the height of the water at a horizontal distance of 0.75 meter from the origin they are asking. That is, they give the parabola is open downward. So if I take this vertex as origin, if it is a 0.5 meter, the parabola reaches a maximum height of 4 meter. Then this is the curve. So this is the fountain. The fountain reaches a maximum height of 4 meter. It is a 0.5 meter from the origin. Now they are asking what will be the height of the fountain if it is 0.75 from the origin. That is, if it is 0.75, there will be a corresponding height, isn't it? That height is I think as y1. What is this y1 they are asking? So if I say this point as 0.5, 4, then this point is 0.75, y1. We have to find out this y1. And they gave the curve already, it is open downward. So given curve is open downward and the vertex is not 0, 0, therefore equation is x minus h the whole square equal to minus 4a into y minus k. So if I take this one as vertex, this is open downward, then vertex is h comma k, that is equal to 0.5 4. The equation implies x minus 0.5 the whole square minus 4a into y minus 4. I have to give this one as h and this one as k. Now to find 4a, I can choose this point. It passes through the, because fountains are starting from the origin only. Therefore, at 0, 0, equation becomes, substitute x as 0, 0 minus 0.5 the whole square minus 4a into 0 minus 4. It is 0.5 the whole square, it is 0.25 equal to 4a into 4. So 0.25 minus into minus plus by 4 equal to 4a. I am finding the value of 4a. Therefore, equation becomes x minus h, x minus 0.5 the whole square equal to minus 0.25 by 4 into y minus 4. This we should keep it as 1 because this is the equation of this particular fountain. Now, if it is a distance of 0.75, then the height may be some y1. 0.75, y1 is a point on the parabola. Therefore, 0.75, y1 lies on the curve. But this point, then equation becomes 1 implies instead of x 0.75 minus 0.5 the whole square is minus 0.25 by 4 into y1 minus 4. So it is again 0.25 the whole square equal to minus 0.25 by 4 into y1 minus 4. Shall I cancel 1.25? So it is 0.25 equal to minus 1 by 4 into y1 minus 4. From this I have to find out y1. So let me write here. Therefore, 0.25 into 4 is minus of y1 minus 4. That is 1.00 is minus y1 minus 4. So minus 1 equal to y1 minus 4. minus 1 plus 4 equal to y1. Therefore, y1 is 3 meter. So, the height of the fountain will be 3 meters. So, height is 3 meter at a distance of 0.75 meter from origin. So, height of the fountain will be 3 meter if it is 0.75 meter from the origin. So, this is. Now, next question number 4. An engineer designs a satellite dish with a parabolic cross section. So, a parabola is given. The dish is 5 meter wide at the opening and the focus is placed at 1.2 meter. So, the dish opening, there is the width of the dish is parabola is given, and also the distance from the vertex to the focus is 1.2 meter. That is also given. Now, position a coordinate system with the origin at a vertex and the x-axis on the parabola's axis symmetry. So, if the vertex is 0, 0 and if the axis of symmetry, that is axis of the parabola is x-axis, find the equation of parabola they are asking, and also they are in need of the depth of the satellite from the vertex. Now, if the parabola is having x-axis as axis and vertex is at origin, then the parabola will be opening rightward, isn't it? So, the parabola will be opening rightward if the axis is x-axis and the vertex is 0, 0. The vertex is origin. So, if it is open rightward, then this is the width. The width is given as 5 meter. That means I can say this one has 2.5 and this one has 2.5. And then the focus they told is 1.2 meters. So, this point is 1.2, 0. Then I can say if the depth is x, then this point is x, 2.5 or x1, 2.5. Then I have to find out the length x1 value. Now listen here. Let the curve be open rightward because axis is x-axis and the vertex is 0, 0 is given. Then equation is y square equal to 4ax. They gave focus is given, then focus is a, 0, that is 1.2, 0. Then equation of parabola is equation of dish is y square equal to 4 into 1.2 into x. That is y square equal to 4 plus 48, 4.8x. This is the equation of parabola. This is the answer for the first question. So, equation of parabola we found as y square equal to 4.8x. Now, let the depth be x1 given, width is 5 meter. Therefore, this implies x1, 2.5 is on the curve from diagram. Therefore, 1 implies, I can say 1 as 2.5 the whole square equal to 4.8 into x. From this with 4.8 x1. From this I can find the x1. Therefore, 2.5 whole square is 6.25 equal to 4.8 x1. Therefore, x1 equal to 6.25 by 4.8. So, we say 62.5 by 48. When I divide 62.5 by 48, 1 time 48. 12 minus 8, 4, 5 minus 4, 5 minus 4, 1. So, if I put the decimal here, it is 145. Maximum of 3 meter, 3 8s are 24 because 3 144. So, it is, I can say x1 is 1.3 meter. Therefore, the depth of the dish is 1.3 meter. Therefore, we can say the depth of the dish is So with that, this problem is over. Started from. They are just asking us to find out the depth, and the depth is 1.3 meter. Fifth problem. Parabolic cable of 60 meter portion of the road bed of a suspension bridge are positioned as shown below. So they gave a diagram. Vertical cables are to be spaced every 6 meter along the portion of the road bed. So vertical cables are to be spaced every 6 meter along the portion of the road bed. Calculate the length of the first two of these vertical cables from the vertex. So the diagram is, it's a suspension bridge like so. I have a road and this is the suspension bridge. Touching the road 3 meter. So this is 3 meter and then the suspension bridge span is 60 meter. So this they gave. And then the side pillars are 16 meter. So this is 16 meter. So every 6 meter they have pillars. So like this. I have to find out this height of these pillars at each every 6 meter, and they are in only 2 of these vertical pillars. Now, what are things that we have to understand from this is, the span is 60 meter, that means I can have this one as 30 meter and this one as 30 meter. And then this is 3 meter the road, so this is also 3 and this is also 3. So only the pillar height from the road will be 13 meter. Similarly, this will be 13 meter. So on the bridge, if I take this is as vertex, the curve is open upward and this point will be full length is 30 and this height is 13. So 30, 30 is the point on the parabola. Now, and I need the height of each pillar which is placed at 6 meter difference. So the first pillar will be 6, maybe this y1 be the height, and then the second pillar will be 12, y2. I have to find y1 and also y2. So once again, the problem is of this hanging bridge, the suspension bridge, which is having the vertex 3 meter above the road. That means the total length is 60 meter only. From the vertex I can separate, so each is having 30 meter, 30 meter. The height of the edge is 16 meter, the pillar height is 16 meter from the base. Therefore, if we exclude the road level, only 13 meter is above the road level. So 13 meter is the height of that vertical height, vertical length. Therefore, I can say this one as 30, 13 is the point on this curve. And they need, the vertical cables are laid at every 6 meter. So first 6 meter there will be 1, the next 6 meter there will be 1. That means this length is 6 and this length will be 12. They need the height of the pillars. So in this length, if I keep this one as y1 and this is y2, I have to find y1 and also y2. Now listen here. The nature of the curve is open upward. Let the curve be open upward. Then the equation is symmetric about x-axis, y-axis, so x square equal to plus 4ay. Now we shall take this point as a known point and we shall find the value of a. Now 30, 30 is a point on the curve. Then equation becomes 30 square equal to 4a into 13. So it is 900 by 30 equal to 4a. Therefore equation becomes x square equal to 900 by 30y. I am substituting for this 4a. So this is the actual equation for the suspension bridge. So we shall keep this one as 1. Now for first pillar 6, y1 is a point on the curve. Therefore 1 implies substitute x as 6 square equal to 900 by 13 into. Therefore I can write this one as 36 into 13 by 900 equal to y1. Therefore, I can cancel by 6. So 6 times, and this one is 150. Then again by 3, 2 times, 50 times. 2 150, 25. So y1 equal to 13 by 25. When we divide 13 by 25, 0.0, 5 times 125, remainder 5, so 2 times. So y1 equal to 0.52. This length is y1, but I have to include this 3 meter too. Therefore, height at 6 meter, height of the pillar. And this is right afterwards. Y1 equal to, therefore, pillar height equal to, first pillar height equal to 3 plus 0.52. It is 3.52 meter. They are in need of second pillar height also. So we should go for next one. Again, for second pillar, 12 comma y2 is a point on first equation. Then one implies instead of x square, 12 square equal to 90 by 13 into y2. So therefore it is 144 into 13 by 900 equal to y2. I can divide by 12. So 12 times, this is 7 times 84, remainder 6, 65 times. Again, so we divide by 3, this is 4 times 25. Therefore, y2 is 4 13s are 52. 4 3s are 12, 52 by 25. When we divide 52 by 25, 2 times 50, remainder 2. 0.0 into 1 divide 0, 1 more 0, 8 times. Therefore, y2 equal to 2.08. Again, I have to add this 3 from the road level. Therefore, height of second pillar is 3 plus 2.08. It is 5.08 meter. Therefore, heights of first 2 pillars are 3.52 meter and 5.08 meter. So this is how we can easily do this problem. Next we shall go for 7th problem. As we are doing all the problems on parabola and ellipse first, we shall do problems only on parabola and ellipse, and we shall do the hyperbola problems separately. Now, a rod of length 1.2 meter moves with its ends always touching the coordinate axis. The locus of the point P on the rod, which is 0.3 meter from the end of the contact with the x-axis, is an ellipse. Find the eccentricity. That is, able to follow the problem. There is a rod which is 1.2 meter. This 1.2 meter is touching both the x-axis and the y-axis. There is a point P on the rod which is 0.3 meter from the end up. So this is 0.3 meter. 0.3 meter. And there is a point P. Then the remaining will be 0.9 meter. This is the case. And if I allow this point to move, and this locus of this point will be a ellipse that we have to find out. That is, I have to prove the locus of this point P, if it is allowed to move, will be an ellipse. So we have to find out the equation of the ellipse, and also I have to find out the eccentricity of the ellipse. There are several methods, but we should do by this method. This method is, let me draw one PM perpendicular to x-axis and the PN perpendicular to y-axis. Then automatically we will be getting a 2 right triangles. So let me keep this one as A and B. So am I getting APN, a right angle triangle? PNB is another right angle triangle, and we should keep this point as theta. This angle as theta. Now we shall see. So this is the length x1. So this is x1, and this length is y1. So this point P is x1 comma y1. Now let me draw PM perpendicular to x-axis and PM perpendicular to y-axis. Let angle MDP equal to theta. Then shall I say from diagram, since these two are perpendicular, this PM and PN are perpendicular, NP is parallel to OB, NP is parallel to OB. Then this implies MP is parallel to OB, then these two angles are equal. Then this implies angle MBP equal to angle NPA, since corresponding angles. Therefore, we kept NBP as theta, but therefore angle NPA is also theta. So, this is also theta. Now, am I having two right angle triangles? So, in right angle triangle, PMB, am I having y1? y1 is the opposite side of this theta. So, shall I find sin theta? Sin theta is opposite by hypotenuse. Sin theta can be written as y1 by hypotenuse is 0.3. Similarly, in right angle triangle, NPA, for this theta, x1 is the adjacent angle. Therefore, shall we find cos theta? It is adjacent by hypotenuse. Therefore, cos theta is adjacent is x1 and hypotenuse is 0.9. Now, am I having the value of sin theta and cos theta? Let me use the identity of sin theta and cos theta. What is that? We know that cos square theta plus sin square theta equal to 1. That is x1 square by 0.9, the whole square, y1 square by 0.3 the whole square equal to 1. So is it not x1 square by 0.81, y1 square by 0.09 equal to 1. Therefore, is it an equation of an ellipse? Therefore, locus of P of x1 comma y1 is an ellipse. So I proved this equation gives me an ellipse. They are asking us to find the eccentricity too. So here x1 square is 0.81, which is greater. Therefore, a square is 0.81 and b square is 0.09. So a is 0.9. Therefore, eccentricity for ellipse is given by the formula a square minus b square by a. It is 0.81 minus 0.09 by 0.9. Shall we write this? So when I subtract this, 0.72 by 0.9. That is clear. If it is difficult for you to maintain the decimals, shall I write this one as 72 by 100 root by 9 by 10 E equal to, there it is, root 72 by 10 into 10 by 9. So E equal to 72 means, is it not 9 into 8 by 9, 10 cancels. Then it is 3 into root 8 by 9. So it is root 8 by 3, that is 4 into root 2 by 2. This is the value of E. So we found the value of eccentricity E. So with that, this problem is solved. So if you do by this identical method, this trigonometry identity method, this problem will be extremely easier. So we found the equation of ellipse, we found the equation of this curve which is an ellipse, and also we find the value of E, which is 2 root 2 by 3. Now we shall go to next problem, 8th problem. Assume that water is issuing from the end of a horizontal pipe 7.5 meter above the ground. Describes a parabolic path. Understanding there is a pipe of 7.5 meter from the ground and water is flowing from that pipe, which is a parabolic path. The vertex of the parabolic path is at the end of the pipe. So pipe end is the vertex. At a position of 2.5 meters, so we shall see. So there is a pipe 7.5 meter from the ground. From here, water is flowing to the ground. This is the structure. This is the vertex, they say. Now, at a point 2.5 meter below the line pipe, say they take a 2.5 meter from the pipe, below the pipeline, the flow of water has curved outward 3 meter from the vertical line. So it is 3 meter. So from a distance of 2.5 meter from the top of the pipe, when they measure the water, this is 3 meter from the pipe. If it is so, to the end of how far beyond the vertical line will the water strike the ground? They need this length. What will be this length from the pipe they are asking. So if I have a proper curve, shall I have this is the pipe. So water is curving out. That is it. So it should have the curve. So which is a parabola. Shall I say as open downward? So this is the vertex 0, 0. And this length is 7.5. From the end of 2.5 from the vertex, this length is 3 meter. And if I keep this one as x. Now can we say the point this is 3, 2.5. What is in the fourth quadrant? So minus. So if this length is x1, then y1 is 7.5. Again it is minus since in fourth quadrant. So I have to find out this x1. So this is the problem. Now let the curve be open downward. So it is symmetric about y-axis. Therefore, equation is x square, but downward, so minus 4ay. So this is the equation of the parabola. Now this is the known point. So let me take the known point. Now 3, minus 2.5 is a point on the curve. Then the equation becomes x is 3 square minus 4a into minus 2.5. So it is 9 by plus 2.5 equal to 4a. Therefore, equation becomes x square instead of 4a, that is minus 9 by 2.5 into y. This is the equation of the parabola. So now the unknown point is x1, minus 7.5. So if I take that minus x1, therefore x1, minus 7.5 is a point on the curve. Then equation becomes x square is x1 square equal to minus 9 by 2.5 into minus 7.5. So x1 square is minus into minus plus 2.5 and 7.5 cancels exactly 3 times. So 9 into 3. I need x1. So it is root of 9 into 3. Is it 3 root 3? Therefore, water strikes the ground 3 root 3 meter from the pipe. Therefore, water, shall we say, water strikes the ground 3 root 3 meter from the pipe or from the pipe. So this is the length of this water from the pipe which is striking the ground. So with that, this problem is over. Now we shall go for 9th problem. On lighting a rocket cracker, so rocket cracker is lighted and it gets projected in a parabolic path and reaches a maximum height of 4 meter when it is 6 meter away from the point of projection. So a cracker is lightened, so it reaches a maximum of 4 meter if the distance from the point of projection is 6 meter. Now, finally it reaches the ground 12 meter away from the starting point. This is 12 meter, that means this is another 6 meter. Then what is the angle of projection they are asking? Suppose if I draw this one as an angle, so they need this theta, this angle of projection they need. So it's completely different from all the remaining problems. They are asking the angle here. So once again, rocket cracker is lightened from this point. It reaches a maximum height when it is 6 meter from the point of projection. Then after it reaches 12 meter from the starting point, it touches the ground. So if it is, so what is this angle of projection they are asking? Now let me take this curve as a parabola which is open downward. So here it is 0, 0. And this is third quadrant. Then this point is 6, 4. The third quadrant both are negative. And this point is 6, minus 4. So let me take any point. Now let the parabola be open downward. Then the equation is again x square equal to minus 4ay. Now can I take this point minus 6 minus 4? Minus 6 minus 4 is a point on the curve. So then the equation becomes, instead of x square minus 6 the whole square minus 4a into minus 4. It is 36 equal to 4a into 4. So 36 by 4 equal to 4a. Therefore 4a can be written as 9. Therefore equation is x square equal to minus 9y. So this is the equation of parabola. Now we are going to approach in a different way. They are asking the angle of projection. So in order to get the angle of projection, what we are going to do is we are going to differentiate here. We study differentiation in our last study itself, so we shall differentiate with respect to x. Then x square differentiating. X square differentiation is 2x minus 9 into y differentiation with respect to x is dy by dx. Therefore, shall I say dy by dx is minus 2x by 9. Okay. Now all of you listen carefully. Differentiation means what? Slope of the tangent, isn't it? That means dy by dx means tan theta. Tan theta is minus 2x by 9. Therefore, again the point is projected at minus 6, minus 4. Tan theta is once again minus 2 into x value is minus 6 by 9. So tan theta is 12 by 9. If I divide, is it 4 by 3? So from this angle of projection theta is tan inverse of 4 by 3. So at the angle of tan inverse of 4 by 3, the cracker has been projected. So with that, this problem is over.